Okay guys, so today I wanted to do something a little bit different. This is an issue I've been working with for a while, and it's basically, if you remember the video, or if you've seen the video I did where I created these little bendy cloth-based physics blowy guys, I don't know what to call them, but and then transporting that animation to bones. So like this one is the cloth simulation, and then this one is just the cloth simulation transferred to bones. If you watch that video, you may have been like, well, what's the advantage, or why do that? The cloth looks good. If you export it, it's really large because it's all like shape keys. This is smaller. It's going to be just a bone-based animation. A lot more kind of compact and useful for games, but it doesn't look the same. You can kind of see that there's a difference. Another example of when this is useful is if you're doing just rigid body. So I've gone and modeled this dam that I want to explode, and how it'll crack up and then kind of fall down into the canyon here. The thing about that is that, look at all those objects. I mean, we're going to go through how to create the simulation. There's other videos on doing it. Basically, you'd use this cell fracture add-on for Blender to destroy something, and then use physics and forces to kind of make it explode. The thing is like, that's 300 objects. If I exported that to any other, like a game engine or something like that, as a contiguous object, it could be problematic and a bit expensive to save that as an animation, because it's going to have vertex animation. It'll be shape key. I mean, in this case, the objects, it's just going to be individual transforms on each one of these objects, which is fine. You can bake that. But each one of those objects is going to have its own animation. So if you tried to join that together for an export, or if you wanted to export it as a bunch of individual objects, it's not super efficient. And in some cases, depending on the target engine that you're working with, you'd have to be able to activate the animation of each one of these objects in some sort of a script to get it to work. So in my case, I was working with WebGL, as I do, and trying to go into like Mozilla Hubs or A-frame, and then when you export just this individual objects and select them all, using a collection, and export as a GLTF, each one of those objects has its own action baked into it, so that in order to play back this simulation in the engine, you have to send a signal to play each one of those animations. They're going to play at different rates depending on the engine and how well it syncs. You're going to just get some weirdness in the simulation. So what I can do, as I did with the cloth physics guy, is I can bake all of this animation to bones using to an armature, and make a single object out of all this, and then keyframe or skin this object to those bones that I've created, so that each one of those bones is what's causing the animation. It's much more efficient. Then you only have to trigger one animation, which is a bunch of bones doing their thing. If you watch the cloth physics tutorial, you're probably like, well, that was a pain in the ass. Sorry for the curse. But it really is. Like, think about that. I'm making a bone for each one of these objects, and then applying bone constraints to each one of these bones, in this case 300. So let's just show that this is actually 300 bones. Each one of these objects has a bone inside of it. Let me select the armature just to make that clear. They're what's causing all of this animation. Okay, when you can see they're all lined up, And when this thing plays, it's all of the bones doing all of the movement of the objects, which that's a lot of work. However, I'm going to show you how to make it not so much work because we're going to go into scripting, and this is the script that does all the work for me. So I'm going to cover the scripting of this. Basically, it's like an add-on, but it's really just a script. I could make it into an add-on, but it'd just be extra work. But what happens is, well, actually, let's get into it, and I'll show you how it works. So we're going to make a new general. We don't need to save this. Let's start with our default cube. We're going to make a physics simulation. Pretty easy, okay? We'll select that. Let's play around with this and talk about how to make that busted into pieces, okay? There's a tool, an add-on. If you go into Preferences, in Add-ons, and you search for Cell, this ships with Blender, Cell Fracture, you'll turn that on, and once it's on, you'll get an extra menu in your quick effects called Cell Fracture, okay? If we bring that up, you get all of this kind of heavy menu that shows different ways you can create. You can basically take this thing and make it cell fracture. So let's just do it once. And, we'll hide our original cube. So all I did in this case was bust it into 4 blocks, a bunch of different cells. Let's undo. Let's go back to Quick Effects and look at the other ways to do it. So in this case, it used its own particles, didn't have any. We can use own verts. Set our number of objects that we want to create, and let's try that. Same thing. So what do you want to do if you want to bust this thing into pieces? There's another option. If you look at the Quick Effects, for doing it with the annotation pencil. So you can go and take this annotation pencil, this little tool right here, and draw. Now when you click that, it's going to be drawing based, it's drawing a kind of the same thing as a grease pencil in the viewport based on the 3D cursor. If you pull down and you set it to surface, then you can draw, and it draws this line across the surface, okay? That's what we want to kind of do with this. I'm just going to draw some fracture lines. Give it enough to work with. I'm not going to be too precise, but all right, so we'll do that. Now, let's bring up our Quick Effects. And then this time we're going to go over here and choose the annotation pencil. And let's make it something impressive, like 300. Put a little noise in. And we'll set the recursion, which is how many times it'll fracture beyond its original kind of guesstimate of how this thing should break up. We'll set that up to 1 and make it random so that it'll happen 25% of the time. You can change, you can have an interior material if you want. Best to do that now if you want to have some different look. There's tutorials on how to do this. I'm not going to go into too much detail about that. Just to save time, we could apply a volume mask. We don't need to do that. I'll show you how to do that in a minute. And then recenter. And the main thing here is you want to make sure you put it in a new collection. I'm just going to call this fractures. And then go do it. So now we're getting some busted up object here. It's going to take a while to compute. And you can see it's not exactly following the lines, but it does a pretty good job of putting more detail where you've done this close-up squiggly stuff and then busting it further out. So let's let it do its thing. All right, now we have fractures here. Let's hide our cube just so we can see them better. If you want to get rid of these lines, you could just erase them, or you can go up here under View to the bottom where it says Annotations and just do minus on the note to turn it off. That'll get rid of it. So now here's our, it did a pretty good job of busting this thing up. Like more detail here and then not so much on the back. It'll be interesting to see how it works. All right, so now to get this thing as a physics simulation, we want to apply a physics rigid body to every one of these objects. And remember, there's 300 of them. So let's, first before we do that, add a plane mesh so we can make this thing react against something. So I'm going to scale up the plane. In that plane, I'm going to put, go to physics and just turn on rigid body. And instead of active, which would make it fall because of gravity, we want to make it passive. It's going to be what the floor that this thing is reacting to. Now we can hide that for a second. Oh, it also put that plane in the fractures, which you don't want to do. So scroll to the bottom of that and just move it out to the main. So this is kind of an interface thing with, see right now it's just, there's a collection and there's a collection fractures. Let's move that into the scene collection so we don't do it. So that anything we put, we'll put into collection here so that we can keep them separate. It's not that important, but you don't want to be selecting fractures and then also selecting other objects too, because we're going to, at some point, we're going to be using that as a key selector to do some, run the script. So plane has rigid body. Now we just need to select one of these objects. Just make it something that you know to come back to in case you accidentally deselect. Let's turn off plane. Okay, so now we're going to add a rigid body to this corner cube. The main thing is it's going to be active. Convex hull is okay. If you want more, you can use the mesh itself, and these aren't complex meshes for the most part. It can slow the simulation down a lot, so we're just going to do convex hull because it looks good enough. The main thing we want to try to do here is change the surface response. I want to increase the friction so it doesn't slide all over the place. And we'll leave the bounciness. This depends on the material you're trying to do. We're going to leave sensitivity alone. Eventually we're going to come back and play with some dynamics, deactivation in particular. But for now, we'll just keep this and then we'll come back to that. So with that selected, this is the reason that we did the separate group here. Just right click and do select objects on the fracture. Now we've got all of the objects in the cube plus this one selected, but it's the last selection. If we go under object and then rigid body, copy from active. It's going to take a second, and it's going to copy that rigid body we just applied to this corner to every one of these other objects. So now they're all rigid bodies. And let's just check that out. Turn on our plane so we can react to it and hit play. So there's our simulation. Not great, but you can see where things are kind of colliding against each other. This is it's creating convex hulls where it can, but they're not making contact 100%. It's not bad, it's okay. The other thing is that every one of these is the same 1 kilogram mass. So if you want to get a better simulation, we can select right click, select objects. Go under Object, Rigid Body, and there's this nice Calculate Mass function. That's going to pull up a bunch of materials. You're going to make sure you choose one. In this case, I want it to be concrete. and it's going to calculate the mass of this concrete based on the real world size. So this cube is 2 meters by 2 meters, which would be like, human size. 6 feet, if you're into imperial units, 6 feet tall, let's say, a little bit more. So each one of these big chunks is going to weigh a lot. So now this block right here weighs 25 kilograms. This one weighs 394, 317. So with all these different weights, the physics simulation should be very different now. So let's watch it. Yeah, so the small ones fall faster. The big ones take their time because they're a little bit heavier. We can do something to make it a little bit better too, where we make the floor, because it's got this less friction. Let's crank that up as well so that things don't slide on it so easily. Yeah, so now when things fall, they don't slide all over the place, and it kind of holds the pile. Alright, so that's pretty good. Let's say we want to simulate that. Now, one of the things you'll notice, there's these dark blocks that aren't doing anything. Those are actually cubes that are in the simulation. They're pieces that are so small that they're not big enough, it seems, to react. I've seen this a couple of times with a lot of selections. So let's let it go to its place. And I just want to select those points. Like I don't know what the deal with them is. Let's just see. You'll see if we select that it is it's one of these cells. Let me zoom in on it. There's nothing there. It's a point. If we move it, we just grab it and move it, you'll see it's there. It's in the simulation somehow. But nothing is, it's not actually one of these geometry chunks. I'm not sure what it is, okay? So we can basically select all of those. Notice, yeah, so there they are, because I was moving them on frame 1. They're not moving anything in this cube, okay? So we can delete those. They are part of, there they are. They're these cells, okay? So it's actually more than 300. It's like 311. So they're there. I'm not sure what they represent. Maybe it's some cell fracture that didn't generate because of the script. There might be a bug in that cell fracture script. But we can get rid of them. So just go over here and delete. So we don't need them if they're not actually showing us something. It's a way to kind of create a smaller file. Okay, so we're back to this. Now how do we... So here's what we've got. We've got this physics simulation that if I scroll through, nothing happens, right? You have to run it. You have to play through it in order for the physics to calculate. And there's other things we can do here. So we talked about making it so that this thing, instead of, it would react to something else. So let's say this is a wall that we want to have and we want to bust something through it. Right now it breaks apart because gravity's just causing it to fall. There's nothing holding it together. So what we can do in our rigid body, so if we go down to dynamics, we can do a deactivation at the very bottom. It's under dynamics here. Check deactivation and say start deactivated. Now we need to transfer that to all of our cubes. So we have to come back to the top. Scrolling. You can see how painful this would be if we had to do this manually like I did the cloth simulation video. But if we select all of our objects now, we have this one that we just changed selected in all of these. So we can go to Object, Rigid Body, Copy from Active. Now it's going to change. Each one of these now has a deactivation so that when we hit play, nothing happens. However, if we add one more object like a do a, doesn't really matter, but let's just do a UV sphere. And pull this here. And let's make it react where it's broken more. The idea that this thing's causing, it's breaking more here because it's hitting here, and then makes everything else. Let's make it a little bit smaller too, because it only takes a little, although it should be relatively heavy in order to make this whole thing bust apart. Think it like a wrecking ball. So yeah, that'll work. Let's see what happens. So we'll make that a rigid body. Active, convex hull's fine. And we don't want to have deactivation on it. We want it to fall. Let's move it way up here. So now, when we hit this, so it's sort of somehow magically creates this block. It doesn't look super realistic, but you get the idea that this thing will trigger the collision. So let's just for grins, let's actually calculate the mass of that. The ball, sorry. Select it. Go to rigid body, calculate mass. Oops. Rigid body, calculate mass. Let's make it steel. Its mass is 32,000 kilograms. Okay, so that's a lot heavier. We will make it so that its friction is a little less because it rolls, right? Let's keep it at 0.5 and see what happens there. So now you get a more realistic simulation with everything reacting, and it looks like it just falls through it because it's so heavy. Yeah. Or it could be a cannonball, right? So let's do, instead of making it fall, let's make it shoot. Just making sure it'll hit. There we go. Let's do a keyframe. So to keyframe this, go to your object and just keyframe the positions here. So now we've got one there, and then let's make it fire and drag it through. Keyframe again. So now we have this object where it's dropping. Why is it dropping? Because it's not set to keyframe for its physics. So to turn on animated, now it keyframes through and it blasts through the object, okay? So if we go, it looks much more realistic. You get this scattering effect. But it's also not reacting. It's going through, which it might, but it's not reacting to its collision with the object. So what we could do is we could find, excuse me, we could find the point right before it goes through, and you can see it's going through these corners because it's like it's teleporting from one point to another. They'll cover this in the other tutorials as well that you'll see on the web if you try to look up how to do more realistic physics simulations. But what we can do is we can keyframe this dynamic or the animated part as well, so we can take it out and just let the physics carry forward there. So like if we turn this, keyframe that to where it's animated, and then actually the one before we want animated, and this one we want not animated. Let's see what happens then. So we kind of just see how it kept rolling there. We imparted some speed to it. And let it go. Because it was so heavy, it just kept on crashing through the object, which is okay. It's like a car accident or something. But what if we wanted to go back and change the mass now so that it bounces a little bit? So let's make it 200 kilograms. Let's see what happens. Then it bounces off because it's going up against a much bigger mass. Let's make it 10,000. Yeah, that's pretty good. So you get the idea here. We're starting to really kind of play around with some physics. Let's make it 5,000. Yeah. And I didn't really blast them apart like I wanted it to. I want something impressive. So let's go back to that 10,000. Look pretty good. Yeah, that's good. All right, we want to figure out a way to get all of this into a game engine or something else, right? So let's go back to scripting and see how to do that. Now, before we do that, let me make that shade smooth. And I want to make it part of the fracture simulation as well, which I may have done when I added it. Yep, okay, so it's in there. That's good. As long as it's in there, it's all good. So all of this, when I select fractures, now we've got these two objects, or really these 300 and some odd objects here. All right, let's talk about how to get that transferred. What we want to do is we want to basically create a bone at the center and take the location of each one of these objects. We also want to take its rotation so that when the physics occurs, the bone gets all of its keyframes from the physics. It's following the object, but it's also taking all that rotation and doing this thing. Okay. So if we look at our script, this is our scripting tab. Bring it up. So let's go into the basics of scripting here. Anytime you see all of these little commands here at the bottom of this window, these are all the things that I've done where I've gone and basically done something in Blender. It's giving me an output here. So you can see where I changed the context, the rigid body mass to 10,000. I told it to shade smooth. So basically, if you have any question about how to write a script on something, you can come in here and execute a command, do something in Blender, and you get an idea of what it is. This is the script that you have to use to do that, okay? So when you want to make a new script, you can just click New, and it'll bring up this text editor, and you can copy one of these commands and put it in here, run the script. Nothing will happen because you have to actually import this bpy module. Blender, if you're not familiar with scripting, basically there are additional libraries, little nuggets of code, let's call them, that have functions and operations and types and variables and things like that that allow them to execute. If it was just wide open, if you could just type a command in here, call it something, it's like it's got an open door, then you could write a script and do it. It'd be cool, but from a security standpoint or from issues with function collisions and things like that, it would be a nightmare to try to handle. So what they do is they package this stuff up so that when you want to do something or make your own add-on to create a function or feature, then you have to go and import the libraries that you're actually dealing with. So if we open my script, let's see, where was I? We'll put it, put it here. It's bone copy pie right here. Here's the script. So the first thing I do is I import bpy, okay? The next thing I do is I create an empty variable called cell object or selected object. And this is these are the, let me see if I can make this bigger. Yeah, there we go. I just control and mouse rolled to zoom in on it. So basically what I'm doing is I'm creating an object that will hold whatever we've selected, but I'm making it empty at first so I can populate. So then I do a for loop. This is all Python. So what you've got is for, and then I create a variable, just a kind of a placeholder variable. For J, it could be for objects, it could be for selected objects, it could be for whatever. This is just a name of something, but to keep it simple, I just call it J. But if we wanted to make it for obcell, object selected, in bpy context selected objects. So this is where we're getting whatever we've got selected in the world. We're actually calling this and saying, okay, what do we have selected in the world? This is how we get that information. And then we say cellob, our array, append, and since we changed the name of it, instead of J, we're putting in the object. So now what we'll end up with is this array will not be empty. It'll be populated with all of the objects that we have selected. And then from there, we can use that selection grouping to say, okay, in the next one, for I in cell object, again, that's just a variable, VG equals I vertex groups equals new, name equals I dot name. So these objects that we're going to have selected coming from cell fractures are going to have names like cubecell, cubecell 0.002, all the way up to a certain number, right? It's basically going to create a vertex group on that object that's going to be the name of the object. We'll need that vertex group later because we're also down here creating bones that have those same names. And when you have a vertex group and a bone that have the same name and you parent those things together, that vertex group gets assigned to the bone, and that's going to take care of our skinning, okay? So we have VG vertex groups. We're creating all these vertex groups. And then from those vertex groups, we have to basically go and select the object's vertices, because when you create a vertex group, it doesn't just add the points of the object. You may want to add less points. You may want to add half the points, whatever. In this case, we're adding all of the points for that particular object, the I data vertices. We're going to add them all to our vertex group that we created. So now then all of our objects here will have a vertex group added to them. From there we go and we create an armature. We just add one. We go into edit mode. We select all. It'll have a bone because when we created that armature, it has a default bone. And then we delete that default bone. Then for E and cell object, our original selection group, we go in and we say armature bone primitive add name e.name. Same thing as we did up here in the vertex groups. We're just creating a new bone that has the name of the object, okay? Then we go into pose mode. And the reason these things are indented is because that means this will run in a loop, and when it's done, it'll go to the next line. This will run in a loop, and when it's done, it'll go to the next line. If they're on the main indent, then they just execute and go forward, okay? So these are loops. These fors are loops. So then it's we go into pose mode, and then we select all of the bones. And then from there, so for bone, in this case, I got a little different. Instead of doing the bpy select object, for bone in bpy context, and that means context just means whatever viewport, window, menu, whatever we're in, that's the context. So for bone in bpy context selected pose bones, because we're in pose mode up here and we've selected all the bones, for each bone in that selection, we're going to go and add a constraint, copy location, copy rotation. And then because our bones are named the same thing as the object that we've created them for, we basically target the name. Okay, so it's going to target the object. So because we've called it objects here and not armature, we're targeting the object that it was parented to for its location and its rotation. And then we come back out, pose select all, action select, and we basically apply this pose Armature apply selected false. Yeah, so there's other things we can add to this. I think I was getting ready to go into and like delete all the constraints then. But I'll show you what this does when we select. So let's just watch this thing in action. Right now, if we look, we've got objects, but no bones, okay? And if we look at the objects and their vertex groups, there's no vertex groups on any of these objects, okay? So let's select everything in fractures, select them, including that sphere, and then run this script. Now we've got a bunch of bones, and they're all positioned at the object. We go into edit mode, they are all positioned there. That's what I was doing, was basically I'm applying the by going into this, that's where I was doing this pose select all. I'm selecting all the bones, and then I'm going and running this pose Armature apply, and basically that applies all of these constraints as the default pose, so that the bones, because when I add them up here, they're all at the world center and they're all on top of each other. And when I first did this, that causes everything to kind of blow apart in a different way when you bind them, because they're not in their original positions for the objects, and the objects will be offset because of that. So this basically just is the same as if you went into pose mode with all of these bones selected and say pose apply pose as rest pose. It's the same as running this apply selected equals false. So like I'm applying the pose that I'm in by going into and selecting all the bones. I'm applying it as the default pose, which will then make it so that when you go to edit mode, all the bones are in their position. Otherwise, they would be at world center. Now that we have all of that, let's go back to layout. It's a bit of a mess, but it's relatively easy to clean up. Okay, so we've got our armature now. Let's find it. It's in fractures, so we don't have to be in fractures. We can pull it into collection if we want. So here's our armature. We're in pose mode. Let's just select one of these bones and see what we have to deal with. So if we look at its constraints, oh wait, no, I'm in edit mode, sorry. Pose mode. Select one of the bones, bone constraint. We've got these constraints on it, right? Each one of these still has its constraints, which is great. That's what we need in order now to get the bones to do their thing, right? They're all spinning around, behaving the way they should because of these constraints. If we went and erased these constraints, the bones would stop moving. So what we need to do is select all of our bones. So go in pose mode, select all. There's all of our bones. Let's make it in wireframe so it's a little easier. Select them all, and then pose, animation, bake action right here. Okay, we're going to bake these bones behaviors to keyframes. So bake 1, and our simulation is 250. We may want to make it go more. We're just going to go for 250. On selected bones, yes, and we want to turn on this visual keying so that it will take it with the constraints applied. If we just bake without the visual keying and don't have the constraints, nothing will happen. The bones will just stay in place. We want those constraints because they're what's causing the action, okay? And then just say okay. It's going to take a second. Or 2 or 3. Because we're basically going to keyframe every one of these bones now. So now we have these keyframes for each bone. Each one of them's got its own series of keyframes, and you can see where sometimes they're moving, sometimes they're not. It's pretty smart about being able to detect when to create the keyframes and when not to. So now we need to select, since I've deselected, select all these, go to pose, constraints, clear pose constraints. It's going to get rid of, excuse me, it's going to get rid of all of those pose constraints on all the bones, okay? So now all of those are just keyframed bones. So something else you should see is that a lot of these, when they animate to a certain point with this floor, they fall through the floor, the bones and the pieces. We can actually delete those later to clean it up even more, and we will. But for now, and what I'm talking about is we'll delete the keyframes, not the bones, because at some point they're still part of the cube above. We just have to figure out where we want to get rid of them. For some reason, they're falling through the floor. Okay, so, and that's probably a speed thing. It's at one point they're here, and at some other point they're on the other. You could fix that in your physics simulation by increasing the steps, but it's kind of irrelevant. I mean, it doesn't matter. If we didn't notice it before we were in wireframe, we don't really need that. It could be internal structures. So now we have our bones baked, but we still have, if we go to object mode, physics, select on our objects here, and they're going to continue to do the physics thing because they're we have to clear that, all of those IK bodies. So to do that, just select all of our objects and then go to rigid body. Thinking we can just go object and join. We're going to make them into a single object. Now, before I do that, let me just show you. Each one of these has its own individual vertex group. Sphere, okay, cube cell. When we select them all and then turn them into a single object by joining them, now they have all of those vertex groups, which are set for each one of the vertices for each object, are grouped into here, okay? And then if we go to object rigid body, we can remove. Now we have no rigid body on that object, okay? Here, okay? So now all the bones are doing their thing, but the objects are locked because we've gotten rid of the physics. However, if we select those and select the armature second, and then go object, parent, armature with empty groups, because all of those bones were named after all the cubes, and then all the vertex groups were named after all of the cubes, they have, each bone and vertex group has the same name, so that when we apply that and parent it with empty groups, everything works. We've applied the skin, and we can turn off the bones. Let's just actually hide the armature for a second so we can see. And now our physics simulation is driven by keyframed bones instead of physics. So it means we can get rid of our rigid body here. There's no physics in the simulation now, okay? All of it's just keyframed from the bones. Which is pretty cool, okay? And let's just go below. Actually, if you want to do this right, go to the side orthographic view and then look and let it carry out for a while. To the point where you feel like you've got most of the stuff that's falling below the scene, below the floor. Just making sure it's everything. Alright, so we get it to there. That's a little piece. maybe that one too, okay. And look at it from the side shot, and then we might be able to see it better with wireframe. Select our armature, bones, and then we're just going to select, I've got to go into pose, or animation actually, which will take me into pose. So I'm in pose mode here, so that when I select, you kind of see I'm only selecting the bones. I'm only selecting the bones that are problematic. All the ones that are up here at the floor are fine. All the ones that have dropped, just want to make sure I get them all. All right, so that means then I'm at 75 keyframes. I can just, and this is my summary of the keyframes that I have. These are all the cells and the keys. So if I just select up to that point, I can delete the keys for this. So if you go to key, delete keyframes, they're just going to stop there, okay? So now going forward, all these other bones above the ground are still going because I didn't have those selected. But now I don't need the keyframes for the stuff below, and that saves on the size of the file, because each one of these keyframes takes up a certain amount of space in the text. We just have the objects, we can leave them there, and that's fine. Okay, so now if we wanted to export this to a game, in this case I'm going to export it to Mozilla Hubs. You can do it with A-frame. Just select the armature, or actually select hierarchy so that we get our bones and in object mode, so that we get our bones and our objects. And we'll, let's see, don't want to export it with the floor, so that we have something. We'll leave the floor separate. We can stand on it, or we'll put this in something else. So anyway, select that and make sure you select it by hierarchy in object mode. File, export, GLTF. You're going to want to include selected objects only, and then under animation, use current frame and make sure we're at 0. Animation, shape keys we don't need, skinning we need, okay, and that's fine. You could control these if you want. We'll call this cube collide, and we'll put it in our 3D models folder. Export, it's doing its thing, thinking. We'll see how big it is in a sec. Alright, that's done. If we go to .3D models, cube collide is 4,788 K, so 4 megs, roughly 5 almost. Let's go to Mozilla Spoke. Get started. We're going to make a new scene. We'll make it, let's do this wide open space. so I'll have a floor to put it on. And from there, I will go to my assets, upload, Cube Collide, right there, open. We will put it at the origin. So here's the cube. People are standing around it. The ball is coming from here. We need to make sure in order to play it that under here on the with the object selected that we have action, or whatever we called our animation. If it was in, just action will be the default. We don't need it to be collidable. We don't need it to be walkable. We might want it to cast a shadow and receive a shadow. Other than that, I think that's good. Now let's turn on the shadows and watch what happens when it plays. Let's save this. Yeah, we'll call this Cube Collide. Save, and let's publish. So notice everything's small, low poly count, materials slow, textures light, file size is relatively small. They call it low. To me, 7 megabytes isn't that low, but that's fine. It's fine for a VR scene, a VR, multi-user VR scene. And I've got videos where I explain hubs if you're not familiar with it, but it's basically a frame, but with like a meeting space. Let's view the scene online. So when you go into hubs, you create a room. So now we're online. And we're going into the room that I just made. So here's our simulation. You can just watch it from without. So you can see the ball rolling. So there it goes. It's just looping right now, so you gotta, when it's done, there it goes. So then if you go in, we'll choose our avatar, enter on screen, mute the mic. Alright, so if we zoom out or move around, and there's our simulation. So that would not work. Like each one of these would have been an individual animation. We would have had to set play, and it wouldn't work nearly as well. But to be able to get this kind of like baked physics simulation from a skinned object, it's pretty handy in lots of ways. Okay. Yeah, I didn't go into texturing or anything like that. We could have baked the lighting on this, and this thing would be rolling and doing its thing, and these could have, if you bake the lighting, obviously, you're going to end up with some weird texturing on the objects, because whatever you bake would probably be from the original simulation state, and that means you're going to have like dark shadows on all of the interior objects, and the outside will be lit with shadows or whatever. So baked lighting in this case is not the greatest idea, and you'd have to figure out some sort of a solution, but your game engine probably deals with like real-time shadows and lighting. Getting this thing baked with all the bones and having a small file is the bigger deal. Okay, so anyway, if you have any questions, I highly recommend that you start playing around with scripting. It's not that difficult, and there's a lot of things you could do to save time with it. So, for example, the cloth character, where I ended up selecting all of the different vertex rings and drawing bones to it. It's like I could have, automated that for the most part, and inserted bones and done all of these and saved myself a ton of time. So Anyway, if you have any questions, leave them in the comments. Hit subscribe if you like the video, and I'll make more. Otherwise, I'll see you on YouTube.